Okay, so we're going to talk about a connection today that sounds, well, kind of impossible. How can a massive ocean current, way up in the cold North Atlantic, have anything to do with the fate of some of the wettest places on Earth, thousands of miles away in the tropics? And believe me, the stakes here are huge. This is from Pedro Dionisio, a lead scientist on the new study that figured all this out. You know, when a climate scientist uses a word like stunning, your ears should perk up. It means something big is going on. So just how stunning are we talking here? Get this, 40%. We're talking about a potential 40% drop in rainfall for parts of the Amazon. I mean, that's almost cutting the rain in half for one of the most critical ecosystems on the entire planet. That's stunning. All right, so let's really dig into this. We're going to see how some of the rainiest regions on Earth could actually be facing droughts on a scale they've, well, never seen before. And that really is the big question, isn't it? What's the link? What's this invisible thread connecting a change in a cold northern ocean to the very survival of tropical rainforests so far away? It's like a climate detective story, and we're about to follow the clues. So who's our prime suspect? It's something called the ocean's Great Conveyor Belt. Let's get to know this massive system that's at the very heart of this whole thing. It's officially called the AMOC. That's short for Atlantic Meridional Overturning Circulation. Bit of a mouthful, right? But the easiest way to think about it is like the planet's circulatory system. It's constantly moving heat around the globe, pulling warm, salty water from the tropics all the way northward. And you can see exactly how it works. That warm surface water flows north, and as it does, it releases heat into the atmosphere, which, by the way, is a big reason why Europe is much warmer than it would be otherwise. Then, as that water cools off, it gets denser and sinks deep into the ocean. From there, that cold, deep water flows back south, and the whole cycle starts over again.
Okay, but here's the catch. Climate change is throwing a major wrench into the system. All that melting ice from the poles, plus more rain, is dumping a ton of fresh water into the North Atlantic. And fresh water is less dense, so it doesn't sink as easily. It's like putting the brakes on the whole conveyor belt, jamming up the engine and slowing everything down.
So you might be wondering, how do we even know what a slowdown would do? I mean, we've only been watching the EMOC with modern tools for a couple of decades. To find the answer, scientists had to become climate historians. And this is where the research gets really clever. To see what might happen in our future, they went way back into the past, 17,000 years ago to be exact. They found a time at the end of the last ice age when the AMOC slowed way down all on its own. So how'd they do that? Well, the clues were basically hiding in plain sight, trapped in ancient climate records. We're talking about data preserved in things like cave formations and layers of mud at the bottom of old lakes. By studying these, they could piece together a global map of rainfall from that ancient time, revealing exactly how the tropics responded. And what they found is something they're now calling a vicious loop. Okay, so this is it. This is where we connect all the dots and see the full picture, from that current in the North Atlantic to the shocking consequences in the tropics. It's basically a giant domino effect. First, the melting ice adds fresh water. Second, that slows down the AMOC. Third, because the AMOC isn't pumping as much heat north, the entire northern hemisphere cools down. And here's the kicker, number 4, that big cool down shoves the whole planet's weather system around. It physically pushes the tropical rain belt further south. And number 5, that southward shift is what triggers these severe droughts. And look at this. This model shows you exactly what that cooling would look like if the AMOC were to just shut down. See all that deep blue spreading across the North Atlantic and Europe? That's a huge drop in temperature. That is the trigger. That massive cooling is what kicks the planet's entire rain system south. And, you know, it's easy to look at this as just a computer model, but as Pedro Dionisio points out, this is bad news. Why? Because we have these very important ecosystems in the Amazon. We're not just talking about any forest. This is one of the most biodiverse places on Earth, and it's absolutely crucial for keeping our global climate stable. And this is where things get really alarming. The Amazon rainforest is holding on to a mind-boggling amount of carbon. Think almost 2 years' worth of all our global emissions combined. If a widespread drought causes parts of that forest to die, all that stored carbon gets released, and that creates this terrifying feedback loop. The consequences of warming would then end up accelerating even more warming. So where do we go from here? Well, now it's all about understanding the risk of hitting a tipping point. That's a threshold beyond which these changes could become permanent. Now, it's really important to separate two different scenarios, a slowdown versus a complete shutdown. Scientists think a slowdown is very likely to happen this century, and even that would cause significant changes. A full shutdown? Well, that's considered very unlikely right now, but still plausible. And if that happened, the effects would be catastrophic. But that leads to a really critical question, doesn't it? If we were to push this system too far and it actually did shut down, could we just turn it back on? And the answer is pretty unsettling. It looks like the AMOC could get stuck in a permanent off state. Think of it like this. If you push a glass off a table, it shatters. You can't just unpush it to put it back together. The system might not be able to recover, even if we completely reversed the initial cause. So what's the bottom line here? I think another quote from Pedro Dinizio sums it all up perfectly. The best way to get out of a hole is to stop digging. The risks we're talking about are immense, these tipping points are real, and the clearest path forward is to address the cause.